So now we discuss all the questions that are asked from the subject process control. So process control from test series 7 in IN. So it is for first question is for 2 marks. So here you can see the question is for 2 marks, and it is from the topic tuning of controllers. It is for 2 marks. So here the question is, so we have a feed forward controller. You can see here feed forward controller. So where the disturbance is forwarded to the input. So where d of t is a disturbance. So here the d of t is a disturbance, and the output is y of t. So input is r of t. So we have a feed forward controller GFFS. So here we are asked to find the output. We are asked to find the system. What is the frequency and the phase shift and the amplitude, so that the error will be less with respect to d of t. So we need to minimize. The question is we have to minimize the error with respect to d of t. So this is a question which is asked. So we know that we have to calculate the error. So in general, we have drawn the block diagram. So in general, any feed forward control system is has the following block diagram. So this is the block diagram. So the Gn of s is the disturbance transfer function, and G1 of s is the feed forward controller, and Gc of s is the controller, and G of s is the plant transfer function. So here we will first derive the generalized equation, and after that we will simplify and substitute whatever components are given. So here we know that output, which is C of s, is equal to the summation here of the forward path and the feedback and the disturbance. So which is nothing but Gc of s into G of s into E of s. This is my error signal which is coming here. Plus, here you can see it's a plus of Gn of s into n of s. So here this is the path. So we can derive E of s as nothing but R of s input minus C of s, which is coming in the feedback. So this is my C of s, plus the other path, which is G1 of s into Gn into n of s. So this is the forward path which is coming. So here when I substitute E of s in the equation 1, I get it as the expression here. So E of s is substituted with this quantity here. So here you can see here, this is my E of s substitution here in this equation, plus n of s. So here we are asked to nullify the effect due to n of s. So I will consider only with respect to n of s, and I will ignore r of s. So here you can see the effect. This is my error expression, steady state error E of ss, and even minus Gn of s by Gc of s into G of s. And here you can see from the given figure in the question that Gn of s, which is this component, is 1 here, and Gc of s is also 1 here. So I can simplify the equation by substituting these values. So here that is what from the given diagram. So it will be minus 1 by 1 into, the transfer function is 1 by s plus 1. So it is nothing but minus of s into s plus 1. So get it as, if I take the amplitude, I get it as √2, which you can clearly see. I'm taking the mod of this expression, and the angle is, or the phase shift is, nothing but minus tan inverse of this component is omega by 0 plus tan inverse of omega by 1 imaginary variable. So it comes as minus 135 degrees, which is nothing but 3 pi by 4. So here the amplitude is √2 and the angle is minus 3 pi by 4. So here the correct option is B.